Welcome to the Beaver's Balance Riverbank Root Garden. Here, roots ask a very simple question. What number makes the power? Think of a root as a way to work backward. If squaring and cubing build numbers up, taking a root is the operation that undoes that work to find the starting point. This connects the abstract equations we write to physical geometry, like the area of a square or the volume of a cube in the real world. To find a root, we look for the specific building block required to construct a perfect geometric shape. Let's start with a perfect square. We need to evaluate the square root of 81. This animation shows how we approach it. We ask, which single number multiplied by itself yields 81? Organizing these 81 reeds into a perfect square grid lets us count the sides. 9 times 9 gives an area of exactly 81. That means the square root of 81 is exactly 9. A square root simply names the positive number whose square creates that total area. It represents the physical base of a two-dimensional shape. Next, let's expand into 3 dimensions and evaluate the cube root of 64. Cube roots undo cubing operations. Instead of a flat area, we are looking for the base measurement of a 3-dimensional shape. This diagram illustrates our pebble pile becoming a perfect volume. Pause the video for a moment and try to recall which number multiplied by itself 3 times equals 64. Let's verify. A length of 4 times a width of 4 times a height of 4 equals exactly 64. Therefore, the cube root of 64 is 4. Cube roots function with the exact same logic as square roots. They simply expand the concept from a flat area to a volume. Not all numbers form perfect shapes. Consider locating a non-perfect root, like the square root of 20. This map shows our stone path acting as a number line. To find the square root of 20, we first identify the nearest known perfect square milestones. 4 squared is 16, and 5 squared is 25. Since 20 is larger than 16, but smaller than 25, we place it between those two milestones. Because 20 is trapped here, its square root falls between the whole numbers 4 and 5. By anchoring non-perfect roots between the surrounding perfect powers, we can estimate their location on a number line. As you apply these concepts to equations, keep a crucial algebraic rule in mind. A principal root expression, like the square root of 25, equals only the positive number 5. However, the equation x squared equals 25 has 2 solutions, positive 5 and negative 5. Mastering these root evaluations sets the stage for exploring irrational numbers and applying the Pythagorean theorem in geometry. Whether building a 2-dimensional grid, a 3-dimensional block, or estimating distances, the core logic remains constant. Roots ask what number makes the power.